Welcome to VCE Master Academy. Today's lesson is the derivative. By the end of it, you'll be able to do three things. Find how steep a curve is at one single point. Expand brackets like x plus h squared and x plus h cubed. And use something called a limit to find a derivative from first principles. If any of that sounds scary, don't worry. We'll go slowly, and every new word gets explained the moment it turns up.
Here's the big idea. A straight line has one steepness. Walk anywhere along it and it feels exactly the same. A curve is different. In one spot it's gentle, a little further along it's steep. So think about walking up a hill. The useful question isn't, how steep is the whole hill? The useful question is, how steep is the ground right under my feet, right now? That answer, at one exact point, is the derivative. That's it. That's the whole lesson in one sentence. Everything else we do today is just the machinery for working it out. To get to that answer, we need two words. First, a secant. A secant is just a straight line that cuts through the curve at 2 points. Second, a tangent. A tangent is a straight line that only touches the curve at 1 point and leans at exactly the same steepness as the curve does right there. Now, the steepness of any straight line is rise over run, so pick a point at x. Then, pick a second point a small step further along, at x plus h. That letter h is simply a small step sideways. The rise is f of x plus h minus f of x. The run is h. So the gradient of the secant is f of x plus h minus f of x all over h. And here's the beautiful bit. Shrink h. Make that step tiny. The second point slides back towards the first one, and the secant slowly tips over until it lies right on top of the tangent. That's the trick behind everything we do today. Let's put real numbers on that. Our function is f of x equals x squared. Question. Find the gradient of the secant from x equals 1 to x equals 1 plus h. Given. F of x equals x squared, and our first point is at x equals 1. To find the secant gradient. Formula, f of x plus h minus f of x all over h. Step 1. F of 1 plus h means 1 plus h all squared. That expands to 1 plus 2h plus h squared. Step 2. F of 1 is just 1. Step 3. Subtract them. The 1's cancel, leaving 2h plus h squared. Step 4. Divide by h. Every term on top has an h in it, so it cancels down to 2 plus h. Final answer. The secant gradient is 2 plus h. Now watch what that gives us. Let h be 0.1. The gradient is 2.1. Let h be 0.01. The gradient is 2.01. The smaller the step, the closer we creep to 2. Remember that number. It comes back. Before we go further, we need to be able to open up brackets, because in a moment we'll be working with f of x plus h, and if f has powers in it, we've got to expand. Here's the quick way. This little stack of numbers is Pascal's triangle. Every number is the sum of the two just above it. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. And those numbers are exactly the coefficients you need. For a plus b squared, the row is 1, 2, 1, so we get a squared plus 2ab plus b squared. For a plus b cubed, the row is 1, 3, 3, 1, so we get a cubed plus 3a squared b plus 3ab squared plus b cubed. Notice the pattern. The power of a counts down, the power of b counts up. And in general, for any positive whole number n, a plus b to the power n is the sum of n choose k times a to the n minus k times b to the k. That's the binomial theorem. For today, honestly, squared and cubed are all you need. Let's practice on the exact ones we'll need. Part A. Expand x plus h all squared. That means x plus h times x plus h. Multiply it out and you get x squared plus xh plus hx plus h squared. The two middle terms are the same thing, so they add up. Answer, x squared plus 2xh plus h squared. Part B, expand x plus h all cubed. Grab the row from Pascal's triangle, 1, 3, 3, 1. Now write x with its powers counting down, 3, 2, 1, 0, and h with its powers counting up, 0, 1, 2, 3. That gives x cubed plus 3x squared h plus 3xh squared plus h cubed. Say those two out loud a few times. They'll show up in nearly every first principles question you ever do. Now, that word limit, here's what it means in plain English. A limit is the value something settles towards. Nothing more mysterious than that. We write it like this: lim, with x arrow a underneath, then f of x equals L. And we read it out loud as the limit as x approaches a of f of x equals L. Look back at our secant gradient, 2 plus h. When h is 0.1, we get 2.1. When h is 0.01, we get 2.01. 0.001 gives 2.001. The answers are marching in towards 2. So the limit, as h approaches 0, of 2 plus h is 2. And here's the key idea, the one that trips people up. The limit is about getting close. H never actually has to arrive at 0, it just has to head that way. Two quick examples. Part A, the limit as h approaches 0 of 2 plus h. Nothing awkward happens here, so we just put 0 in. 2 plus nothing is 2. Done. Part B is the important one. The limit as h approaches 0 of h squared plus 3h all over h. If you rush in and substitute 0 straight away, the top becomes 0 and the bottom becomes 0, and 0 over 0 is meaningless. So we tidy up first. Factorize the top. H squared plus 3h is h times, bracket, h plus 3. Now there's an h on the top and an h on the bottom, and we're allowed to cancel them because h is not 0 yet. It's only heading towards 0. That leaves h plus 3. Now let h go to 0. And the answer is 3. So the rule is simple, cancel first, while h is still not 0. Then let h go to 0. Never, ever divide by 0. Right. Now we put the two halves together, and this is the formula that defines everything. F dashed of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. Look at it carefully. The fraction part we already know. That's the gradient of the secant, the line through 2 points. And the limit part, we already know. That's shrinking h down to nothing, so the 2 points collapse into 1. Put them together, and you get the gradient of the tangent. That single number is the derivative. It's the steepness of the curve at that exact point. Working it out with this formula, straight from the definition, is what we call finding the derivative from first principles. Before we do the full algebra, here's a shortcut that calculators and scientists use every day. If you pick a tiny value for h and just work out f of a plus h minus f of a all over h, you get a very good estimate of f dashed of a. You don't take the limit, you just use a small h. Let's try it. Take f of x equals x squared and let's approximate f dashed of 3. First try h equals 0.1. F of 3.1 is 3.1. Squared, which is 9.61. F of 3 is 9, so the top is 9.61 minus 9, which is 0.61. Divide by 0.1 and you get 6.1. Now try h equals 0.01. F of 3.01 is 9.0601. Take away 9 and you get 0.0601. Divide by 0.01 and you get 6.01. See what's happening? 6.1, then 6.01. The smaller h gets, the closer we creep to 6, and 6 is exactly the true value of f dashed of 3. So an approximation is great when you want a quick number, but the exact derivative needs the limit, and that's what we do next. Our first exact one. Question. Find f dashed of x from first principles for f of x equals x squared. Then find f dashed of 3, given f of x equals x squared. To find f dashed of x. Formula. The first principles formula we just met. Step 1. Work out f of x plus h. That's x plus h, all squared, which we already expanded. X squared plus 2xh plus h squared. Step 2. Subtract f of x, which is x squared. The x squareds cancel, leaving 2xh plus h squared. Step 3. Divide the whole thing by h. Both terms have an h, so it cancels down to 2x plus h. And we're allowed to cancel because h is not 0 yet. Step 4. Now let h go to 0. The h just disappears, and we're left with 2x. Final answer, f dashed of x equals 2x. So at x equals 3, f dashed of 3 is 2 times 3, which is 6. And look, that's exactly the 6 our approximation was creeping towards on the last board. Approximation and first principles agree. It all lines up. Step it up. Same question, harder function. Find f dashed of x from first principles for f of x equals x cubed. Given f of x equals x cubed. To find f dashed of x, same formula. Step 1. F of x plus h is x plus h, all cubed. This is where the binomial work pays off. It expands to x cubed plus 3x squared h plus 3xh squared plus h cubed. Step 2. Take away f of x, which is x cubed. The x cubes cancel and we're left with 3x squared h plus 3xh squared plus h cubed. Step 3. Every single term has an h in it, so factorize the h out and then divide by h. That leaves 3x squared plus 3xh plus h squared. Step 4. Let h go to 0. The middle term has an h in it, so it vanishes. The last term has an h squared, so it vanishes too. Only 3x squared survives. Final answer, f dashed of x equals 3x squared. So f dashed of 2 is 3 times 4, which is 12. So where does this actually turn up? Speed. Say a car's distance from its starting point after t seconds is t squared meters. Between 2 seconds and 4 seconds, it travels from 4 meters to 16 meters. That's 12 meters in 2 seconds. So the average speed over that stretch is 6 meters per second. But now look down at the speedo. The speedo doesn't care about your average for the trip. It shows how fast you are going right now, at this instant. And that is exactly a derivative. Distance is s of t equals t squared. So the derivative, s dashed of t, is 2t. At 2 seconds, that's 4 meters per second. That's your speedo reading at that moment. Average speed is the whole journey squashed into one number. The derivative is the needle right now. Let's pull it together. 1. The derivative is the steepness of a curve at one single point. 2. Start with a secant through 2 points, shrink h to nothing, and the secant becomes the tangent. 3. To expand the brackets, use the binomial pattern. X plus h squared is x squared plus 2xh plus h squared. X plus h cubed is x cubed plus 3x squared h plus 3xh squared plus h cubed. 4. A limit is the value something settles towards as you close in. 5. For a quick estimate, pick a tiny h and work out f of a plus h minus f of a, all over h. 6. And the exact definition itself, f dashed of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. Learn that last line by heart. Every first principles question starts there. Your turn. 6 questions. Pause the video here and have a proper go before you look at the answers, because reading a solution and writing one are 2 completely different skills. Question 1. For f of x equals x squared, find the secant gradient from x equals 2 to x equals 2 plus h. Question 2. Expand x plus h, all cubed. Question 3. Evaluate the limit as h approaches 0 of 5h squared plus 4h over h. Question 4. Use first principles to find f dashed of x for f of x equals x squared plus 1, then find f dashed of 5. Question 5. In words, what does f dashed of 2 tell you about a curve? And question 6. For f of x equals x cubed, approximate f dashed of 2 using h equals 0.01. Pause now. Answers. Question 1. Expand 2 plus h, all squared, and you get 4 plus 4h plus h squared. Take away 4, which leaves 4h plus h squared. Divide by h, and the answer is 4 plus h. Question 2. X cubed plus 3x squared h plus 3xh squared plus h cubed. Coefficients 1, 3, 3, 1 straight off Pascal's triangle. Question 3. Don't substitute yet. Cancel the h on top and bottom first, which leaves 5h plus 4. Now let h go to 0, and the answer is 4. Question 4. F of x plus h is x squared plus 2xh plus h squared plus 1. Subtract x squared plus 1, and both the x squared and the 1 cancel, leaving 2xh plus h squared. Divide by h, that's 2x plus h. Let h go to 0, and f dashed of x equals 2x. So f dashed of 5 is 10. Notice the plus 1 made no difference at all, because a constant doesn't change how steep a curve is. It just lifts the whole thing up. Question 5. f dashed of 2 is the gradient of the tangent to the curve at x equals 2. In plain words, it's how steep the curve is at that exact spot. And question 6. f of 2.01 is 2.01 cubed, which is 8.120601. Take away f of 2, which is 8, and you get 0.120601. Divide by 0.01, and the approximation is 12.0601. Round it, and it's 12.06. The true value of f dashed of 2 is 12, so our little h gave us a very good estimate, and that's the derivative, from the ground up. VCE Master Academy, your guide to VCE success. You're mastering VCE Maths, one concept at a time.